So, Paul, we've seen that we think we have a bunch of gas orbiting a big red star. Now, I would think that if we looked at several of these objects, sometimes that gas would go in front of the star and we would see an effect. So if we looked at the light over time of a lot of these objects, we should occasionally see like a transit or an eclipse, and that would help us figure out what's going on with that box of gas.
Yes, so just like when in the exoplanet course in the series, we talked about how a planet goes in front of the star, or the star goes in front of the planet, you block out the light, and this can tell you a huge amount, and we can do the same thing here. When the gas goes in front, you wouldn't expect to see anything, because remember, this gas is transparent, so the light from the star is just going to go straight through it. But when the star goes in front of the gas, it should block out the light, and of course most of the light is coming from the gas. The gas is brighter than the actual star. And indeed, you see in about 30% of the time, you do see these sort of eclipses. So there's the light, and then this is the point when the star goes in front of the gas cloud.
Yeah, so we have a lot going on here. For some reason, the object is brighter, and then the gas goes in front and blocks it out. But it's kind of funny. It goes through, and there's a little step here which you can kind of barely see. But then there's this big glitch on this side. So it's almost like the box of gas has two parts to it. It's like there's a bit that's denser than the other bit.
Yeah, and it turns out if you look at the shape in great detail, it turns out there are actually three parts to this gas. There's a spread out diffuse part,
Yep.
and then there are two narrow bright parts. And when the first narrow bright part goes in, you get this very sharp drop in brightness when that goes behind the limb of the star. And then here, a short time afterwards, the second one goes behind. And then a bit later, the first one comes out and the second one comes out.
Okay, so it's a very complicated structure. What happens if we zoom in? So
Yep. So here's the idea of what we've got going on here. We've got the gas cloud and the two bright things inside it, one in the middle and one a bit off centre. And you see now one then the other goes behind, then one then the other comes out, giving you this double step up and the double step down.
right, okay, so all right, so a very funny system. Hopefully this is all going to make sense eventually, but I guess maybe we need a little bit more information.
Yep, there's more information in these light curves. These light curves were obtained using photoelectric photometers, which is a new technology which allowed you to measure the brightness on an absolute linear scale, very precisely on very short time scales. And when you apply it, in this case, to U Geminorum, the very first of these things discovered, see what's going on here.
Oh, so it's flickering, and so this is only flickering every 10 or 15 seconds or so.
Yeah,
And
no
so
particular
it's
pattern,
flickering
it's
up
jumping
and
around
down.
in brightness on very short time scales.
Right, and then that flickering, when that thing goes behind the red star, disappears. So we know what's flickering. We know it's the bright thing that's going around the red star.
And also, the fact that it's flickering tells us it's very, very small. We knew it's small anyway because it cuts out, the light drops very abruptly, so it must be a small thing that's going behind. If it was a big thing, it would take a while for it to move behind the limb of the star and cut out. But also, if it can flicker on 15 seconds or so, that means the sound crossing time must be no more than 15 seconds, which means you're talking about something much smaller than a typical star. So a small variable thing in one of the bright spots. So I guess our model is now going something like this. We're now getting, it's probably the off-center of the two spots that's doing most of it, is randomly flickering like crazy.
Okay, interesting. So let's talk a little bit about this bit. So there's something funny going on where the object, as it goes around, that's flickering, is brighter, and then it sort of fades away, depending on exactly where in the orbit the object is.
Yeah, you'd normally expect the light to be perfectly flat, except
Right.
where it was going into the eclipse, because it's just looking at the gas cloud, and the gas cloud should look the same from every angle. But it seems that we're actually seeing more light when the gas cloud, not really on the reverse side, but sort of a little bit off the reverse side. It's kind of like this gas cloud, or particularly the bright spots within it, are beaming their light in a backward direction, not quite aimed towards the red star, but not far off. So like a torch. So if you imagine, for example, that your head was the red star, and this is our bright spot, it's shining, and when it's on the far side, the light is shining towards us so we can see it. When it's around the near side, it's shining away from us, so apart from seeing Brian's face illuminated, we can't see very much. But it's not pointing straight towards the red star, it's pointing a bit of an angle, because you see it's offset to one side. So you've got a torch going something like that around the red star.
So you need to put a torch on your next diagram.
Yes.
Well, at least a version of a torch.
Yeah, what it's kind of like is that it's the thing that's flickering is like a glowing surface painted on something opaque. So what I've done is I put a black slab and I've painted a flickering white thing on the surface. So when the black slab, now we can't see it, we just see the black slab. It's on the far side, we can start seeing the flickering, but we see it more in this case after rather than before the eclipse. So it probably needs to be angled the other way to make it work the way we actually see. So this flickering thing is only visible from some directions. It's like something painted on a surface.
All right, I'm not sure if I'm any the wiser at this point, but I guess what we're going to need to do is put together even some more information to get a better picture. And I'm afraid this is the way science often works, is you get a bunch of complicated things that you got to build up in a story, but you don't really know what's happening till you get all the pieces of the puzzle together.